Okay, so for today's session, we'll start with Spark and let's understand the Spark, how it helps in the ecosystem, right? So Spark basically it's beyond Hadoop MapReduce. What that means, anything that we can do in MapReduce can be still doable with Spark, but it's beyond that capabilities. And in a way, it's a different framework basically. MapReduce is one framework. Spark is another framework, which is also a distributed processing framework. And this is basically helping more to on the in the job performance and the velocity of the workloads compared to MapReduce. If you see in the olden days, like when we create MapReduce jobs, it's meant for bulk batch jobs, but when it comes to the performance and the velocity of the load, like if you have to do something like a more real time, so those two factors, it is a little bit lagging. The MapReduce is not able to, whenever you need some batch has to happen on a performance consideration. Like if performance has to be like within, you have only like let's say 30 minutes time left and you have to finish it, and it may be a limitation sometimes. So, and for those reasons and other reasons is like we need the data to be processed more frequently than like nightly or hourly. Or so in those two scenarios, wherever you have a need, still you need like a batch, then Spark is helping now, and that was a solution. Okay, but again, still till today, MapReduce is still meant for large scale data processing and batch reporting, and that's still there. Okay, you don't need to use Spark for everything because mainly it's because in memory. That's the main. That is the advantage as well as the disadvantage. So because it's in memory, you have to use it to only certain account, certain to certain level. Okay, because in memory is generally, if you go beyond certain limits, it's not like a, still, I mean, you are able to go to maximum extent than olden days. In memory also you can extend to a lot of terabytes nowadays, but that doesn't mean that for everything in memory is the solution. Okay, so yeah, it uses in memory, fault tolerant, resilient distributed RDDs, keeping intermediaries, inputs, outputs in memory instead of disk. So basically, mainly it will avoid the disk read writes. That's the advantage of in memory, right? That's why it's faster. So that's why performance is better and workloads compared to MapReduce. And the another important thing, the MapReduce is generally force the jobs in sequential MapReduce framework compared to Spark process the jobs in more distributed processing framework. That's a bigger difference. Okay, so those are the fundamental differences. And it's basically, as the tagline says, it's scalable and highly available and secure. That's the tagline for Spark, right? So what are the other areas where Spark is being used by, if you use the DAG, which is a very popular execution engine, which is mainly used in terms of machine learning, particularly, uh, you know, if you use this, I mean, DAG basically represents the directed acyclic graph. So which is basically to generate such complex uh, execution. So you need the Spark power. Otherwise, it's kind of very difficult to do this before Spark came into picture. Okay, so now Spark brought a very good advantage for the platform, and now mostly DAG runs always on Spark now. And the Spark performance and enhancements, particularly for the interactive. What that means, whenever you need query performance, generally like low latency kind of queries, if you need something to, you run some query and it has to be more interactive, like user should not wait for like, otherwise if user submit a query and the hourglasses keep rolling, that means the user gets frustrated, right? So in such scenarios, if wherever you have a direct user interaction to do some queries and looking for the low latency querying use case, so Spark performance will be very helpful. And primarily this supports Scala, Python, Java APIs, and basically the Spark, actually Scala, I should mention that particularly Scala is a native language for Spark engine. When Spark was built, the Spark framework, it came up with a native language, basically Scala. It's very similar to like a kind of R type of language, with this object-oriented language, and it comes with simple functions, like small simple functions, but it will do uh, great things, like very big things. It can, if you just use a small function that can, in otherwise, if you don't have this type of functions like Scala or R type of functions, just to do the same work, you have to write like hundreds of lines of code just to achieve a small functionality. But now these languages made it so easy now. If once you get familiar with Scala or Python, a lot of these things will make things so simpler, as long as you know what you're doing. I mean, the functionality. So with a simple line of code, you can achieve that. That's the biggest advantage. And primarily, if you are working with Spark, like a Scala supports, and Scala, I don't think you can execute Scala code somewhere else except Spark. But R is not like that. R is an open source and it can be executed anywhere else. Okay, and even Python and other things. But that's why Scala is a little bit unique. It works natively with Spark, and but it's also very powerful. And if at all, I mean, again, there is no preference here. Like if you're already comfortable with Java or Java APIs, that's also you can use. But somebody is good with Python, they can continue, and Scala or various purposes, right? All these are like different purposes. So also it can support all the lot of machine learning algorithms, which are part of Spark is meant for also machine learning, graph processing and stream processing. So this is like a multiple purposes. Spark engine can be used in multiple ways: for stream processing, for machine learning algorithms, for graph processing, and for interactive querying and all that. Okay, so yeah, I mean that's the primary concept of it. Let's get into the little bit of architecture side of things, how Spark actually works on the Hadoop platform, from basic architecture point of view, right? So it has a client. Basically, think of this Spark on ARM. Okay, ARM is basically one of the execution engine. So once the Spark is enabled, and basically if the Spark is already mostly it comes with by default, right? Until unless you disable it or not, but generally Spark is part of the ecosystem. Any Hadoop installation you do, Spark automatically comes, and which use the leverage the ARM engine. That's where the distributed processing engine. ARM is basically distributed processing engine. Okay, so Spark can work on that, and yarn resource manager is one of the thing that controls the resource part of it, and driver, which is some like a client that actually submits the Spark application master and then the yarn container, and that goes to executor. So I mean, these are the some basic terminology of Spark, how it handles the work. Okay, so there will be a driver, the client, whatever you submit client, that is called driver, and it submits the request to Spark application master, which is on the ARM container. And the ARM container, basically the resources are managed by ARM execution engine, and the executor is also on ARM container, but that's a component that helps to actually execute that. So it's basically for the purpose of distributed processing, this mechanism is working as a driver. No, basically the components are separated, because you need to, it's like a regular HDFS thing only, but only difference here is Spark being a Spark in memory. It doesn't need to work with the file system. It similarly, just like it works with file system, reads and writes to the disk, it is going to leverage Spark here in memory, basically very similar type of work. In the Spark interactive shell, what happens, right? So Scala interactive Spark client, for example, you submit some Scala job, which is like in the command prompt, and basically it goes to resource manager, and resource manager text, and let's say you have some DAG schedule or something, then task schedule. So basically this is like internal uh, how it maintains the number of jobs that will be submitted for the Spark interactive shell. It's like a Unix. If you work on Unix, right, pretty much like it has a bash shell, can you know like you have multiple shells, right, like at different levels. Similarly, Spark has, when you install when you install HDF Hadoop ecosystem totally, Spark interactive shell will also be installed, and you will be able to leverage that interactive shell to run the commands and run the Scala jobs and all that. Okay. So okay, let's see this in the bigger picture, right? So how really Spark fits into the overall ecosystem. At least in the, if you see in Amazon world, right, we called Amazon EMR earlier, and which has a HDFS file system behind the scene. But also, I mean, I haven't mentioned here actually the Spark internal architecture, like an in-memory architecture here, but it could work with the Amazon EMR. Basically, we could use Hive, we could use Spark, we could use Mahout. Mahout is for the machine learning. The Hive is for more like a batch querying. Spark is for more like interactive querying, right? In this context, but Spark has multiple purposes. But this, in this context, what is showing is just the how it could interact with Amazon EMR, Spark. Okay, and yeah, I mean, just this is one of the typical setup, like Amazon EMR. It could scoop into Amazon RDS, and then data pipeline it could put into. It's also can have a bidirectional Amazon NoSQL database to Amazon EMR, or Amazon S3 bucket to Amazon EMR. So this is, it could also all the way finally go to Amazon Redshift. So this is like some typical architecture. Generally, people might use it. But now this is where you'll know more on this Spark. Why Spark on Amazon EMR? Spark generally it works on Hadoop file system, right? So always try to remember when we say Hadoop platform doesn't need to be always on Amazon EMR, or it doesn't need to be Amazon product, right? It's an open source Apache Foundation of frameworks. It could be done by open source as it is, or it could be done by some of the products like Cloudera or Hortonworks or other platforms. But in our context, we are always looking at every component what we work is how and why on Amazon EMR. And we're trying to understand those differences and advantages. Okay, because you need to be able to justify when you are going to a project at client place. Sometimes you may need to make a decision like what is the right thing to do and what is the best thing to do for your scenario. So at least from my experience so far with working at least 3 products, I felt Amazon AMR is giving more value, at least for wherever you don't have a baggage to carry something in the legacy systems. So why Spark, right? So you can actually deploy small and large Spark clusters in minutes quickly. The same if you want to deploy your Spark clusters in a regular environment, it takes a lot of time, and just like any other HDFS system, right? The only thing here is in-memory type of instances. You have to, in case of Amazon, it's like number of EC2 instances with more suitable for in-memory purpose. In-memory, like that means like mostly RAM will be high on these EC2 instances, because Amazon Cloud, if you go to AWS, when you choose your EC2 instance, you can choose a type of configuration. You want to have like more of a machine that is more having more RAM, or having more CPU, or having more hard drive. So you have various configurations there. So you can choose for Spark purpose. You can choose the one that has more basically it's like any other Hadoop system, but EMR also do the same thing. and integration with EC2 Spot Market, Amazon Redshift, Amazon Data Pipeline, Amazon CloudWatch. All these are native tools for Amazon. So you have an easy integration with all this. And specifically, you have to want to highlight on EC2 Spot Market. What that means, I'll explain maybe in the next slide. Actually, that's very important thing. When you are working with um, Spark clusters, you are looking for EC2 machines, which are like memory intensive, right, or memory hungry. So those things, it'll be expensive a little bit. So environment. So this is what we'll talk about that. So Elastic Spark with Amazon EMR. So Spark, you just basically, when it comes, the Spark, it's like Elastic, right? Basically Elastic memory, Elastic Spark. So that means your memory, it becomes like more of a flexible elastic model. How? Elastic Spark with Amazon, basically Elastic Spark fit into Amazon EMR architecture here, right? So you may be having any type of application like a portal application app or something. So what type of source, whatever it is, right? The data. This is one, again, when I show some of these architectures, like this is one scenario, not
Yeah.
necessarily this is the only way to do. Okay.
Kashogr, we cannot see your screen.
Screen.
You lost the screen?
Yeah. I don't know whether it is my problem or everyone.
Can anyone else confirm, please?
Yeah, we cannot see screen.
Yeah, we cannot see that.
Oh.
We lost the stream.
Is it just happened or you missed
Just now only. Just now.
now it's-
Your voice is breaking and you got removed from the.
Okay, let me. I reshared again. Let me know if that is helping.
We can see.
Now it's coming, right?
Yeah.
Okay, yeah, maybe some internet problem then. Okay. Okay, so this is the diagram. You saw this before or only now it came?
We saw this.
Yeah, I saw this, right? Okay, so yeah, basically what happening here, so whatever is the source data, it's coming through the streams, okay, and it's going to Spark on EMR. What that means, instead of going to, it's like in-memory location, right? On EMR, you have a Spark. Basically, you have a Spark cluster, not only HDFS cluster, like a file server cluster. Also, you have a Spark cluster for the in-memory purpose. And the streams data straight go into Spark EMR, and the process data will go into S3 buckets. And from the streams, it could also go to some of the Kinesis clients. It's called Kinesis client language. It's like a command prompt. That application could also work in bidirectional way to DynamoDB, or it's putting the data into S3. So this is one setup of how Elastic Spark used with Amazon EMR. Okay, so we'll talk about some of the detailed like streams and Kinesis KCL, Kinesis client. So some of these are core components of streams of Amazon Kinesis. But I want you to understand all this terminology and what all the tools that are, because there are so many things on Amazon AWS, but what specifically we are using them, what we are going to use. You need to be aware of all this. Okay, coming back to the interesting topic, that this particular one I just mentioned earlier, why it is very important, because Spark is a memory hungry one, because it is like it's all about in memory, right? So you need to have a lot of RAM.
Kashogr, we cannot see the screen again.
Okay. Something happening here. Screen share. Okay, I'm sharing again. Maybe my internet maybe keep coming out or something. Yeah, please let me know in case if you are missing. Hopefully, I don't need to restart my machine, but the connection seems to be okay for me.
Yeah, we can see it now.
So I'll keep moving. Let me know whenever you see some problem. So mainly this is a very memory hungry. So when you build, since it is memory hungry, instances types mostly use like there are a lot of instance types, EC2 instance types, M1, M2, CC2. There are a lot of categories. In each one has various level of uh, memory. Some things are like in gigabytes, some things in even terabytes sometimes. So in memory, generally you see hard drive being terabytes, not in memory, like a memory RAM being terabytes. But in Amazon you could get even RAM in terabytes. Okay, so but that's again that's it's going to be expensive. So we use Spark clusters only for the needs what we need, and that's why not only building Spark cluster in Amazon environment, when you build, use them efficiently for only the things that you need. Don't just because you have a Spark cluster, don't submit everything to that, because it's a little bit expensive than regular servers. Okay, and that's the reason you need to be aware of cost very well. And there is something called spot market, EC2 spot market, and which is more like a bidding process, right? So in Amazon, in a regular market, generally what you do is, if you need to build a cluster, a Spark cluster, let's say you might decide, okay, I want like a 100 gigabytes of RAM in memory servers. Like I need 20 servers, for example. You build your cluster, but that is like you don't know how much of that will use always. So there may be a lot of unused capacity, and there may be sometimes you need more than that, and so it's all like it's not easy to maintain that. But when it comes to EC2 spot market, you can actually bid like a eBay or anything like that, right? So there will be a lot of unused, like let's say I bought like 20 servers with you know a lot of memory with me available, but I'm not using it. So it is a lot of money wastage for me. So like that, a lot of people in the market might say, okay, I have a lot of this unused ECT capacity. If you bid it, like they might, sometimes you might get it for like 1/10 of the price, real actual price, or it could be more. So you have an ability to schedule your you can bid it, like you can say, whenever the price comes to this price, I will buy it. So because it's cheaper than regular price, and you have a need to use it. So like that, there's a process called spot market price, and you can bid on the large memory instances with the fraction of the cost. Okay, so here some example given here. For example, instance type, you could say I want M1 X large, the 63 nodes, and on-demand cost is $31 per hour. But on the spot market, so you could get even for $4.41, which is like, it's a really fraction of what you really get on demand cost. Okay, so this is the level of savings you will get. But again, it's not always, if you are going for a bidding and trying to say, you don't know you will get the bidding win or not. But that's why when you design whatever the basic thing, minimum thing you need, you always design and go by on demand reserved instances. But if anything additional that you wanted to use for special scenarios, you go for the spot market and schedule your bidding. Okay, so that's just a brief idea to how people use it. Okay,
Sir, yes, sir. I have a
Mhm.
question on the pricing
On the pricing.
here. Yeah, I read somewhere, if I'm correct, there is a 10-cent charge per prediction. Is that, and I
For
believe
the
that is also done in the EC2, right? So
so the question is, there is a $10 for the prediction means like
yeah, but if I want to predict an outcome, like do some prediction using machine learning language,
right.
I thought there is a 10 cent per prediction, 10 or 15 cent prediction
Oh
charge.
yeah, because that is if you are using the ready-made. I mean, for the prediction model, you build your prediction model, and no. If you are depending on service, managed
Yeah.
service, right?
Okay.
Yeah. So the price for that, what you're talking is about managed service. If you want Amazon to, if you are depending on a managed service, everything is a charge. They go
Okay.
by even for predictions. Yes, there is a cost method for that also. But cost is not very straightforward in Amazon. That's the problem. Like
Yes.
we need to be very clear in what service we are using from Amazon, because there are so many services, and for everything. Suppose I think I was telling earlier, sometimes putting data into S3 bucket may not be a charge, but if you're taking data from S3 to outside of data center, then they will charge for that also per each gigabyte what you take out, and even for the network input output, no, the get and put.
Okay. So if I build
So
my own model, then there is no per prediction cost. If
correct.
it is
So yeah, so
okay,
basically, if you are
then
building
I
your own
basically go with
prediction model,
the cost here. Okay.
correct. Yeah. So in your own prediction model, they don't charge for the prediction per prediction, but for the infrastructure, right? Whatever you use to do that machine, you create your prediction model out of some infrastructure. So for that infrastructure, you will be still charged. But
Okay.
if you are using the prediction itself, I mean the model itself from Amazon ML machine libraries, like if you are using the packaged service basically of Amazon, then you will get charged for prediction per prediction.
Okay.
Yeah. Similarly, for even Lambda function also, like per transaction, per computation, they charge like that. Lambda charges like first million computations are free, 1 million or something. That means like you could do so many things with before that limit, but once you cross that limit, per transaction they'll charge some cents.
Okay.
So that's how a lot of services are like that only. It's all like on-demand service. So here the important thing to learn, especially Spark, right? So I kind of mentioned this earlier, but again to reiterate, Spark, there are 3 different use cases at a high level. So it could be used for stream processing, it could be used for machine learning, it could be used for interactive SQL. Okay, so if you want to just get into inside of this little bit, what stream processing is, right? It could consume and process real-time data. Basically, streaming is nothing but more like a real-time processing. Real-time, it can consume real-time data, it can process real-time data, and we do use for that. Basically, these are the components that we use. Kinesis is one of the component. Kinesis has multiple components. Again, it has Kinesis streams, it has Kinesis firehose, various things you will see in Kinesis. But as part of the ecosystem, like Kinesis is going to help to consume the stream processing, stream data, and behind the scene, Apache Kafka is another alternative for Amazon. Amazon Kinesis also have a product to process the data, real-time data, not only consume, it also has a product for processing real-time data. But another product is Apache Kafka, which is an open source product, equivalent one. Okay, if any of you familiar with Kafka, and if you wonder that why Kafka is not being used, basically instead of saying it's not used, the same framework of Kafka being used by Amazon just by wrapping with another product. Like behind the scene, Kafka still the same mechanism. So Kinesis, you'll see something like Kinesis streaming, which is very much the Kafka. Okay, so what it does is basically it does the data streams with Spark streaming on Amazon EMR and perform streaming analytics and rewrites to Amazon S3 and clusters. So this is basically this is the stream processing purpose, and the next purpose is machine learning. Apache Spark on Amazon EMR that includes MLlib, which is machine learning libraries. and there are a lot of algorithms in that, so you can use for your own average also. But Spark, why Spark? Because again, machine learning needs a lot of intense processing when you process the machine learning uh, algorithms. So Spark is the very effective engine to help work with machine learning. Okay, because it has to do a lot of storing in memory data sets and compare, and it has to come back with the results quickly. And the interactive SQL, as I told already, low latency and interactive queries you could also use. Generally, like what we use for interactive, as I told earlier, Impala or Presto or Spark SQL. But even HiveQL can be used. But HiveQL is, if it is more interactive, it is better you go for the Spark SQL. But the drawback of Spark is it's not like it's less like SQL, but it's a subset of SQL. Not everything like exactly SQL. HiveQL itself is a little bit medium level of SQL. Spark SQL is like a really low level. It's not, if you compare in the tiering, like tier 1, tier 2, tier 3, the ANSI SQL is like the superset of SQL, and the next level will be HiveQL, and the next level will be Spark SQL. Okay, and Apache Spark on Amazon EMR, it leverages the EMR file system. It can have ad hoc process, and yeah, it also can use all the the regular tools like ODBC, JDBC connections. So just jumping into the stream processing here, right? So when we talk about streaming, and generally Hadoop streaming, a lot of people think that streaming is something a SQL, because I mean, it is a general meaning of streaming is like real-time data process type of thing. And if you see here, it's a utility to create, run MapReduce jobs using executables or scripts to replace map and reduce functions. Okay, so this is what Spark is doing now. So anything that was a map and reduce job, which is in a more sequential mode, so now it's taking into Spark, the streaming jobs being created. And the pros and cons, better to know here. It allows the programming of any language: Ruby, Perl, Python, PHP, R, Bash, A++, all of that. And yeah, what is the con here? Yeah, it's limited to mapper and reducer functions. So you may not be able to go beyond certain map and reduce functions, what you want it to do. So input from standard in, output standard out. So these are all standards. And penalty versus map reduce APIs. Yeah, so it's basically performance penalty versus map reduce APIs. So I think new learn here, but this is just a understanding. The use cases, some of the use cases for streaming, right? Unstructured data with wide variation of formats. It could accept any format basically. And text processing, analysis using scripting, and mathematically complex scientific applications like bioinformatics and genomics. So some of these are real use cases that are being used in the industry now very heavily. So maybe I think Nageshwar, I think some of these areas are very useful for your project too. It depends on what you use, but we'll deep dive into some of these later on. But just to give you a heads up on this, some of these are mainly used for complex scientific applications in the healthcare industry. The create mappers, reducers without relying on Java, reuse existing processing code. So these are some of the use cases. Now let's jump into the Kinesis streams. I think I just need to finish a couple of slides maybe, then we'll jump onto the lab. But this something important, so let me not skip it. So Amazon Kinesis stream. Well, when I talked about earlier, like streaming, just generally Hadoop streaming, and it could be implemented in any platform, right? Hadoop streaming could be done in any platform, but in Amazon, we use Amazon Kinesis streams for that reason. So It's basically a ordered sequence of data records. Okay, each record in the stream has a sequence number that is assigned by streams. The data records in the stream are distributed into shards. Yeah, this is some new terminology that you will hear in Amazon Kinesis streams. So when you have a lot of data, the data records are coming as streams. They're distributed into shards. Shards is nothing but it's like group of data records simply. Okay, so a stream is composed of one or more shards, each of which produced fixed unit of capacity. Each shard can support up to 5 transactions per second for reads, up to maximum total like 2 MB per second, and up to 1000 records per second for writes. So this is the read rate and this is the write rate. That's the difference. And up to the maximum total data write rate of 1 MB per second, so which includes partition keys. Yeah, there is a concept called partition in this also. The data capacity of your stream function for the number of shards that you specify for the stream. So yeah, I mean the total capacity is basically sum of all the shards capacity. Okay, so the other terminology you will use here, producers and consumers. The producers put the records into Kinesis streams. For example, if a web server sending a log, data goes into stream as is a producer. And the consumer get records from Amazon Kinesis streams and process them. So these two are the key components, like the three actually: shards, producers, and consumers. When you talk about these three are the key components. And the other two that these are like more of applications, like you build your Kinesis stream applications. And the other one is there is a client library which will compile into your application to do the job. Okay, so this is what you need to see and understand to how the whole process works. So you see all these the sources, right? It could be coming from some EC2 instance, or EC2 instance, like let's say you build your web application or something on EC2 instances, like any Linux server or anything, right? So that might be your source, or it could be some client or mobile client, some traditional server, or AWS IoT also is like a source. So nowadays most of the IoTs are producing a lot of data. It's like a streaming data, right? So these are all producers. They're like basically sources. And the streams will have shards within it, and there are consumers. Consumers could be mostly EC2 instances because you are putting your Spark here, Spark clusters. Okay, using Kinesis streams, you are basically consuming into your Spark engine, your Spark cluster, and then you are processing it into one of these. Either you're processing into S3 or Elastic MapReduce or Dynamic DB, or so there are any outlet. It could be any outlet. These are some few examples here. Okay, the main key point there is it's all about real time. It doesn't wait for the batch. So here you will understand a little more. Basically, we're talking about the same like producer and consumers and shard. So all the producers will be keep on giving the data into stream, or like Kinesis streams, which will be having a lot of shards. Like you can add more or scale it based on the capacity needs. Sorry, one second. Yeah. And the worker components, which is basically consumers, will be, this is where you'll see Spark here, all the Spark clusters. You could have multiple Spark clusters, or they will be the consumers consuming that. Okay, so I think that's pretty much, I mean, again, how it works and all, there is nothing different than general HDFS technology, but only difference in the Kinesis streams or the Spark engine related things, it is all purely in-memory based. That means the servers you are using to place your Spark engine or to use the streams, you're basically using the more of memory focused servers. The configuration wise, you select them properly. All right, so I'll stop it here. I'm running like 5-6 minutes over on this. Now let's jump into the lab. So you will experience that. It's an interesting, actually very interesting exercise, and this will cover multiple things. This is what we are going to do today. Okay, let's spend some time on this and try to understand this carefully and do this, try to finish it as well. So basically the exercise we're going to do is serverless architectures with Amazon DynamoDB and Amazon Kinesis streams using AWS Lambda. So if you remember, initially we did some exercise with AWS Lambda, though it was meant for serverless. I mean, Lambda is mainly meant for serverless architecture. We didn't really use the purpose of it. I think Balu was also asking this question earlier. How is this serverless architecture Lambda function is? So here you will see that in this exercise, how it's being used as a serverless architecture. Okay, I mean for Lambda purpose. But again, you have to use Amazon DynamoDB, Kinesis streams to have the whole functionality set up. So let's look for this. Let me ping this to. This should be available mostly free, I believe, but let me see. Mostly. I think, yeah, except the one that you saw, everything else should be free, or maybe this is the lab will do. Let me log into my system too. Okay, I'm going to use. Any questions there? I mean, from anyone, like just to understand the terminology, or any confusions or anything that you learned before, but you need any clarification, let me know. But otherwise, we'll get moving on the exercise now. So let me go here and search for the catalog. Okay, go to labs. Delete that part. You should get that. Yeah. So okay, this has some credits, but it is available though. Hopefully it should work here. Yeah. This needs 55 minutes. So yeah, hopefully you can complete by 10:30. Mostly you should be able to. They say 55 minutes, but you can finish it. So here what you learn really is multiple things, right? Let me quickly walk through what we are trying to do here. Part lab. In part one of the lab, you will create a Lambda function from a blueprint, and create a blueprint means like you don't need to write the code required for the Lambda function. But in real scenario, you have to start coding. But for now, initial exercises, you will this will be given for you, and then you'll create an Amazon Kinesis stream, then trigger the function with the data from your stream, and monitor the process with Amazon CloudWatch. That's the first part. So what this means, basically, Amazon Kinesis stream is streaming the data, and you are setting up a trigger that functions whenever that data streams. This triggering the Lambda function is working on that, and you're monitoring. It's very similar to how you did earlier, but now the second part, you will learn the basics of event-driven programming to Amazon DynamoDB. Okay, and its stream feature. Amazon DynamoDB also has its own event-driven functionality. So that's we will learn that, and you will walk through the process of building a real-world application using AWS triggers, which combines the DynamoDB streams and Lambda. So basically, this will help you to look at how the streaming data comes in using Amazon Kinesis stream, and how the event-driven programming happens using Amazon DynamoDB. And again, this is one of the outlet. In this exercise, what you're learning, finally the data going to put into Amazon DynamoDB. That doesn't mean your streaming data will always go to Amazon DynamoDB in the real scenarios. That's one of the destination. It could be. Okay, so that's the two part there. And basically, end of this lab, we should be able to create a Lambda function. We should be able to create Amazon Kinesis stream, and we should use CloudWatch to monitor Kinesis event data, which is triggering Lambda function. Create Amazon DynamoDB table and insert items. Enable the Amazon DynamoDB streams feature. This is a additional thing, so which you are going to learn. Then configure and troubleshoot the Lambda function. So with all this, you will be able to start taking any streaming data, at least in one of the way, into Amazon DynamoDB in this case. Okay. So suppose you could also do this same exercise. The target could be Amazon EMR. There's nothing wrong. Okay, but in this exercise, it was given with Amazon DB because mainly we want to enable the Amazon DynamoDB streams feature also. That's why. Okay, so here you'll definitely use putty here. So hopefully you all downloaded that. If not, you can download that from here. It's also given in the link here, but we already had that before. I thought you already downloaded in the initial first session. I made you download this, so you would need that. Yeah, other things are all already we learned, so there's nothing much here. Just get started on this and let's see. If you have any issues, we can work through. But hopefully it should be fine. So, and one thing notice here, when they say they have a Lambda function blueprint already available, it looks like it's a Python code. Okay, so when you open that code, you take a look at it and see what generally the code is. It's using Python code and a small basic function, because it's not really doing much function here other than just helping to trigger. So nothing to worry. Actually, some of the commands are already given here for the as part of the exercise, so it's easier to navigate. That's the whole purpose, right? So initially, you will start getting these commands one by one, and when you're doing, just pay attention to this, what you are doing and why are you doing, because later on, when we start doing real projects, you have to start remembering these things. Not like a spoon feeding comes, right? So you have to, this is initially to get yourself familiar and make your hands dirty a little bit. These are very helpful, but it doesn't mean that you'll always have step-by-step approach like this. So that's why you build that thought process right away. When you're doing, think about it and don't worry about time too much, because time is something that even if you can't finish in the first iteration, maybe you do one more time. That's not a problem. Just rushing and just doing without understanding is not going to help you. You need to know every step why we are doing. Yeah, this is a little lengthy one, but still I don't think it takes really 1 hour. Should be like around 40 minutes or so.
Keshav sir?
Hello.
Hello, Keshav sir.
There is. Tell me.
Actually, నేను ఇక్కడ కాపీ ద ఫాలోయింగ్ AWS Kinesis పుట్ రికార్డ్ అని 55th స్టెప్ దగ్గర స్ట్రక్ అయ్యానండి ఒకసారి.
Yeah, let me see that.
షేర్ చేయనండి.
Yeah, I think you need to share your screen. The command, the put command, right? Put.
పుట్ కమాండ్ దగ్గర అండి.
It's not working.
అంటే AWS is not recognized by an of అండి. సో
No, did you created this stream before? First step.
yeah, and actually
You named the same. You
yeah,
named the same my stream, right? The name of stream we created.
yeah, my stream.
Okay. Yeah, it should work. I mean, because once you spin off the, where are you trying this command?
Actually, I'm using my Mac.
Share your screen.
Yeah.
One second. Let me. I think I have to allow you to share. Okay, you can share it now.
It's showing like AWS is not recognized.
Just say AWS -help.
AWS is not working.
So 1 second. AWS itself is not working. 1 second. I think you missed something here on the steps. You connected to the same EC2 instance, right? Whatever you have.
Public key through AWS.
Public. Yeah. The key, and otherwise you cannot connect actually. So you're able to connect there, right?
Yeah. So is this the one for the connection? SSH -I and
Yeah. After you, that's a PEM key, right?
yeah. There might be some problem on this.
Yeah, you're able to connect it all. You already connected, right?
So I had done this. So is this right? And
So where did you put that? Did you set up in your putty? You downloaded. Then can you go to your putty client?
Terminal. So
Yeah,
the terminal. This is the terminal.
No. Can you go to actually your go to desktop where you have your.
So here. So this is the PEM file.
Okay, you downloaded that, right? Okay,
Yeah.
But where is your putty client?
I'm using Mac, and so there won't be putty for me. So I'm using the terminal.
Yours is Mac. Okay.
Yeah.
Okay. Got it. Okay. Sorry. Okay. There must be some other issue going on than Mac. No, if that is the case. 1 second. For Mac, I think there are some special instructions given there, right?
Yeah. So beginning from 46, these are the instructions for Mac and Linux.
Hello. Can you check once whether it is already connected or not? Hello. Yeah, can you please check once it is already connected or not? I like I have config something. You can still is in the system, or it is connected to that AWS EC2 instance?
So you go back to your terminal again. 1 second.
Okay.
So when you downloaded that,
Yeah.
So they asked to download the PEM key or
PEM key and
PEM key only, right?
yeah. So here EC2 private key page, return to a quick labs, download the PEM or PK. Click
Yeah,
download.
that's fine. Once you download it, you have to configure that somewhere. In case of PuTTY, we configure that in the. But here, where do you configure? That's what I'm trying to see. Downloading is one thing.
Okay. Is that about the permissions only? chmod.
Oh, permission also important. Yes, yeah.
Yeah, we channel. So after that,
Permission also important because you need to have access to that, right? So, but not only that, actually, did it say somewhere you have to configure on the
no, not actually.
on the terminal? Go up 1 second. Terminal. I saw something there. Terminal.
This is where it starts with OS X.
Yeah. Okay. So this section is for OS X and Linux users only. If you are using Windows, skip to next section. So yours is OS X, right? That's the main thing, right?
Yeah, that's the one.
Okay. So
DNS.
scroll
Public
down.
DNS.
Go step by step. Yeah. I just want to make sure
Yeah.
you didn't miss any step there.
Yeah, public DNS copy. Yeah, copy.
What is the status of that EC2? Can you go back to your server again? Is it in the running state? Yeah, running state, right? Okay. Yeah. Sometimes that is also okay.
Then download the EC2 KP, like download the PEM. So
yeah. Save the
I have
file.
already downloaded. I will download it again. I will just delete all the files. EC2 PEM. Yeah, downloaded. PEM is here. Save the file in the directory of your choice. Okay.
Yeah, you saved it to the file directory. Okay.
Yeah, I left it in the downloads.
Okay. And enter the following commands now. So now you change mode that, right?
So chmod now
Is that the path exactly same where you are doing change mode?
Yeah, the same one.
So now can you see if it is already having a 6 means it should have at least RW. Does it have RW?
Yeah, already it's having, it's not 600 and RW or so I need to change it to chmod.
It's not changed.
No, I haven't done. I deleted all the files, so I'm doing it.
Okay.
So now we change to RW.
RWX, yeah, okay.
So now it's
600 and 6, right? Not 7, right? 6.
Yeah,
okay.
600.
That is RW. Yeah, okay. No X. Okay. Okay.
So just RW.
Yeah, that's enough actually. Yeah, read right because you should be able to.
Now it's asking like.
Okay, now if you execute the next step, what it's saying, that's where you're getting the error, right?
Yeah, SSH -I.
So can you do one thing?
Yeah. Sure.
Do just say sh. Because maybe your bash shell is not in one. Okay, just say sh.
SH. Okay.
Then space AWS and see if you're able to do anything with that.
No such direct syntax error.
And 1 second, let's understand. It's
no such file.
No such file. Okay, so just say immediately use AWS and just enter directly. No, just see without anything. AWS.
Okay.
Enter.
Command now.
AWS command not found. So in the bash shell, you don't have the AWS command. What is that? Can you say ls? Just see what is there.
Yeah, this is downloads folder. So
in this folder,
okay.
what all you have?
Regard as of the GitLab spam file is
So
this.
this is like your terminal and your download folder, right?
Yeah. Only.
Except this, everything else is whatever you have before.
Yeah.
Okay. I haven't worked with terminal before, but let me see. Somehow it is not recognizing your. I don't. How is it going to connect to? It has to connect, right? First, you see the command that they gave. The next line
Okay.
is
Yeah.
once you connect to the server. First, you have to connect to the server. You download it. That's fine.
Okay.
But then you have to connect to that. Where did you connect it to that for the
This
server?
is the one. Either SSH minus I should be the connect.
Did you connect it? No, already this is acting as your SSH client, right?
Yeah.
Okay. Did you do that first one?
So public. So I'm doing now. So at first I have done.
Yeah, you have to use your public DNS there, and user also you're using EC2 user, right?
Yeah, easy to use.
Okay, yeah, that's the default. Yeah.
So do we need to leave these arrows only or remove those?
You don't need arrow.
That need to be removed. Actually.
You need to be removing. Yeah. Even PEM key.
Okay.
I don't know whether
This
need to
arrow
have
need
that.
to be removed.
Yeah, it should be removed.
I think so
Should be
because
removed.
that's not recognizing that.
The name is like.
One second. Download slash. That's a PEM key.
Tab.
No, it's case sensitive. Careful. .pem. Then second. No, after that.
So do we need to have any space here and
Go back to the command, original command, and the
this one.
see that yeah, whatever they give.
Okay.
Right next to PEM key, what is there? There is
EC2 user at the rate DNS, public DNS. That's what I had given.
yeah, that bracket definitely you have to remove, and there is no space there on
Yeah,
the.
no space. So let me check. Is the similar for the Windows and
No. When you're coming from PuTTY, it's totally different. Like you just look for your PEM key. I mean that your
okay, PAM file.
yeah, PEM file, and then it will recognize automatically from there. You don't need to.
Let me try this. So something happened. Let me check. No, not found.
No, the syntax only something wrong here when you're connecting. SSH interactive. I downloads PEM.
After PEM, there must be some space, I think.
Yeah. Oh, because you're already in the download folders. Yeah. Try that. Try that.
Yeah.
Yes.
Okay.
Connecting.
Yes. Yeah. Okay. Now connected.
Now it's connected.
Yeah.
It's
Now you
connected
execute
and
it.
it is going easy to use.
Yeah. See, you see that EC2 user connected to the IP.
Yeah.
Now it should work. Yeah.
Thanks, Anand.
Yeah.
If we give IP config, then it will show where we are.
Yeah.
Yeah, it's connected now.
Yeah, because AWS command only works when you connect to the server.
హలో అర్జున్.
Hello. Balu. Tell me.
అదే ఇప్పుడు ఈ వన్ మంత్ సబ్స్క్రిప్షన్ తీసుకుంటే ఈసీటీ ఇన్స్టెన్స్ ఎన్నైనా తీసుకోవచ్చా? ఐ మీన్ ఒక 6-7 అలా ఈసీటీ.
Yeah. No, you can see the subscription that you take for 1 month. It's like no, but not like any EC instance you can take. You can use any lab available part of the Quick Labs
ఓన్లీ
or labs. Not
Okay.
like you can create any number of instances outside in the Amazon. This is part of the Quick Labs package.
అంటే జస్ట్
But once we are done with this exercise, right? So eventually we have to have our Amazon account, and obviously you have some free services available. They're small, like basic EC2 instances you can launch. But if you want bigger sizes, that it will go into your on-demand
అంటే
charges.
6 నోట్ క్లస్టర్
So yeah,
నార్మల్గా క్రియేట్ చేసి
subscription doesn't help for that. When we because these are all like once you use it, it will be gone, right? It'll be gone after 50 minutes, 30 minutes, whatever after the exercise, because they're only temporarily creating these things for test for lab purpose. So for your original project, you should never use this. This is only meant for labs temporarily.
ఓకే. అంటే ల్యాబ్లోనే నాకు
Mm.
ఇంట్లో క్లస్టర్ అని క్రియేట్ చేయొచ్చా 6 నోట్ క్లస్టర్?
No. Only, I mean, your subscription is available for Quick Labs. Any, you can use any session number of times. That's the advantage. No, did you take it already, Balu? Or
రేపు తీసుకోవాలి.
yeah, I'll call you after this. Actually, let's see now.
సరే ఓకే.
Because a couple of them are you need credits. Otherwise, a lot of them are free, but 2 or 3 in this whole package you need to have that. But I thought of I asked you to take a subscription because mainly you can do multiple times without time constraint. You can practice more at least in the next few weeks after this also. Because that way you will have more practice.
Keshav garu?
Yeah, hello, Kishore.
Keshav, no, once we are done with the lab, I mean, I haven't come to the lab, but if the time expires, so we have to rebuy it, or
Yeah,
we have to
basically,
start.
if you started the lab, generally, if you
Uh-huh.
it has a time limit. Generally, that is enough time to
Right.
finish the lab. But if in case if
Mhm.
it is if at all if it is end, you have to restart again. But you can
So
obviously,
for
because every time it restarts, it's going to wipe out everything what you have.
but I don't have to pay it, right? Or I have to pay it again?
No, I mean, how did you take your subscription monthly or for
No.
number
This is
of
like I
credits?
took yeah, I took number of credits. So.
Number of credits. Okay, then it will be you have to be careful with the time.
Oh,
So
okay.
because suppose it takes 10 credits, right? That means
Mhm.
if you don't finish it in time, it'll end, and then you lose also what you did. So you have to try to target to finish it in the time. But if it is a
Oh,
subscription, you don't need to worry because you can do multiple times,
right.
number of times, again and again. Generally, that's why I thought subscription may be useful, but again,
Okay.
couple of them we need. So at least you see, this will take 10 credits, and there is one more
Mhm.
that takes like 15 or something, and there is one more. They're like around like at least 30 credits. You anyway you need it.
Right. Right.
So
Mhm.
generally, that's why instead of taking 30 credits, if you take 55, I mean 55 means like a subscription is like 55, but
Mhm.
that would actually cover you for almost 1 month. You can have a lot of other things as well. I mean, other than this, and this itself you can do
Oh,
multiple
okay.
times,
Okay.
so you'll get very good familiarity with the additional $25. Yeah.
Yeah. Okay.
Okay. Yeah. If you haven't done, try to do that. But if you already
Yeah.
used credits, then I don't know if you can upgrade or not. But that would be a better idea.
Okay.
Yeah, especially if 2 weeks anyway you're going to use, and if you also
Mhm.
continue for 2 more weeks, it's better actually to continue a
Right.
couple of weeks extra, because not only like some see what we are doing is as part of the course you are trying to do some very basic thing that you definitely need to do. That's what we're doing,
Mhm.
but it
Yeah.
doesn't mean that is only the thing. You can actually try a lot more, which will make you more comfortable, like before even like you do on your own without completely.
Okay.
Yeah, but a lot of this stuff is just to get familiarity, right? Because you haven't used the environment
Yeah.
for the first time you're using, so you need to get familiar with it, explore the all the options and configuration.
Yeah.
Yeah.
Okay.
Okay, and again, don't feel like you need to rush it through at the same time. That's why I was telling, like, sometimes, not only rushing, you also need to understand why we are doing some of these steps. That's important. So then only it makes sense. Otherwise, you'll finish it, but if you don't understand the steps why we are doing, somehow you have to slowly register those things. If you need it one time, two times, three times, but even if you do multiple time, doesn't matter. But make sure you are understanding the steps. That way, when you need to do, you'll start thinking actually solutions. Okay. Yeah, I think we are running a little over on this, but I hope you can continue and see if any. Uh, if you haven't started, first go through the document. I mean, the contents clearly, and try to understand what is to be done, and then you start the lab. Then that way you'll save time, steps wise. Okay, Annie? there is, when you did that exercise, right?
చెప్పండి.
Make sure you, whatever that code you copied, right, you also copy into your some notepad or something, put it on your desktop, so you can revise the code also. You can review the code later on to just go through quickly to understand the code better also. Okay, so some of the code what we are executing, before you close the lab, always make sure you take the snippet of the code whatever you're using and copy into your local desktop or something, so that way you can review the code in the, after the lab as well, just to understand the code better.
Okay.
Because you need to write similar code when you need to write some of these functions. Okay, so that way you will start learning. Basically this is like a quick start, right? So but always the code, I mean, you can always find, there are a lot of forums and all that, like sample codes will be always available. But since you do this exercise, if you review this, you will have the context why you did and what this code is doing. You'll have better understanding.
Okay.
Make a habit of that one in every exercise. What you do when you have some code you are copying, make a copy of it and put it into your local desktop or somewhere. You save it somewhere.
Sure.
Because all the EC2 instances, whatever you are using right now, they will be they will be wiped off right after the lab completion, because those instances are not your own environment. So after these exercises, like once you create your own environment, you can have permanent servers. That way, that's like your own setup, but that will have cost monthly, right? So so, but until you come to that stage, some of these things you keep samples.
So that we can use them as references.
References, basically it's like a reference there, basically code reference. So also it will give you more context, because you did on this exercise, you understand what this code is doing better. And then you can create similar code. It doesn't need to be same, but it may be something similar code you will use when you create your own requirement functions. Okay. All right. And I think Kishore, you're still going on, or you will do it after?
I'm done. I'm done.
Very good. Okay. Okay, and so I think only you two left now. So let's catch up again tomorrow.
Thanks, man.
Okay, no problem. I think keep continuing on this, at least this 1 week, and maybe coming weekend. I don't see a lot of need for a lot of practice also. But the question is, these are all available now, right? I mean, once you are out this and you come up with somebody, I give you some project requirement, right? So you have to start thinking on your own. So for that, this exercise is very important.
Okay.
Okay.
Good night.
All right. Good night.
Bye.